1.5 Solve problems using linear systems. Okay, so let's just recall we can solve a linear system by graphing or using substitution or elimination. For the scope of these questions, I'm actually going to just stick to substitution and elimination because moving forward, graphing is just going to be too time consuming. Okay, so here are some steps of solving linear system word problems. So first of all, we have to determine the variables and write basically let statements. And then we have to determine the two equations. And then we're going to solve them using any of these three methods. Again, for me, I'm going to stick to substitution or elimination. And then what we're going to do, and this is the most important part, is we're going to interpret the results and write a concluding statement. Okay, example 1. This is about finding two integer values, okay? So find the value of two numbers if their sum is 13 and their difference is 5. So what we're talking about here is two different numbers. So x is going to represent the first number, and y is going to represent like the value of the second number. Okay, so their sum is 13. So when we add them up, their sum is 13. But their difference, okay, when we think difference, we think x minus y is 5. Okay, and we have to solve for x and y. So let's choose substitution or elimination. I'm going to choose substitution because isolating for any of these x or y's is going to be very easy. Okay, I'm going to bring over that negative y. We're going to have x equals 5 plus y. And then this is an expression for x. We're going to sub that into the other equation. So we're going to have 5 plus y equals 13. Okay, bring that 5 over. We have y equals 13 minus 5. Y equals 8. Okay, so we solved for y, and now we sub the y back in, and we have to solve for x. X equals 5 plus 8. So x equals 13. Okay, therefore, we can say the point of intersection is 13, 8, but if we think about the actual context of this question, we're finding two numbers, the value of two numbers. Okay, so we can say therefore 8 and 13 add to 13 and have a difference of 5. Let's do another example. This time we're going to talk about two different prices and which one should we go with. Okay, Pietro needs to rent a truck for 1 day. So he calls two rental companies to compare the costs. Okay, Joe's Garage charge $80 for the day plus 22 cents per kilometer. Okay, we know this from grade 9, like the cost equals 80 plus 0.22, let's say it k. Okay, so if we think about the variables that we actually need, and sometimes I do this backwards, c is going to be the cost, and k is going to be the number of kilometers driven. Okay, Ace Trucks charges $100 per day and 12 cents per kilometer. Okay, so there are our two variables and our two equations. We've seen this before when the c is already isolated. So what we have to do is we have to take this and set it equal. We can technically sub it in here or just set the two c's equal to one another. So let's go 80 plus 0.22k equals 100 plus 0.12k. Okay, and our question, what we're going to try to find out is under what circumstances do the two companies charge the same amount? Okay, same amount, that is the point of intersection. That's what that's asking for. So let's bring that 80 over here. We're going to get 100 minus 80, and we're going to get 0.22k minus 0.12k. Okay. And when we divide this out, we're going to get k equals 200. Okay, so therefore, let's sub this back in and let's actually find the point of intersection. But we know that driving 200 kilometers is going to be that like break-even point. So let's go C equals 100 plus 0.12 times 200. 0.12 times 200, I get $24. So 100 plus 24 is 124. Okay, so when we drive 200 kilometers with either Joe's Garage or Ace Trucks, it is going to cost $124. Okay, now the second part. When would it be better for Pietro to rent from Joe's Garage? So specifically Joe's Garage. I always like to draw two lines on a little graph. Okay, Joe's Garage starts at 80 and goes up. Ace starts at 100 and goes up. Okay, your point of intersection is at 200. Okay, so we know that under 200 kilometers, Joe's Garage is going to be more beneficial. Okay, so therefore, Joe will be more beneficial for a trip under 200 kilometers. Okay, so in this example, we're going to analyze a situation where two items are sold, and we want to know how much of each of them are sold. Okay, another one is, for this one, is sometimes you're going to get a number of coins, and you're going to have to decide how many of each coin you have. Okay, so for example 3, the sports shop sells Nike running shoes for $82 a pair, and Air Jordans, basketball shoes for $95 a pair. One day, the sports shop sells 75 pairs of Nike and Jordan. Okay, this is the important part, Nike and Jordan. So these are the two things that we're talking about. So let's go N and J. Okay, N is going to be the number of Nikes sold, should be capital N, and then J is going to be the number of Jordans sold. We know that together we're going to sell 75 pairs. So let's write one full equation based on the number of shoes sold. So N plus J equals 75. And then this is going to be shoes sold, if you want to make like a little note. Now, the sales totaled 6241. So the next equation, what we have to do is we have to write an equation. It's going to equal 6241, and this is all going to be about money. Okay, so we know that Nikes cost $82. So 82 times N, $82 times the number of Nikes sold. Jordans cost $95. So of course 95 times the number of Jordans sold, and altogether this money is going to be 6241. Okay, we have two unknowns, so two variables, and two equations. So for this one, again, I would choose substitution because the N and the J are alone. So let's just move that J over. We're going to have N equals 75 minus J. Now let's sub that in. 82 bracket 75 minus J plus 95J equals 6241. Okay, and let's distribute that 82 into the bracket. So 82 times 75 is 6150 minus 82J plus 95J equals 6241. And let's bring that over and subtract those. Okay, so we have 95 minus 82 on this side So we get 13J, and we have 6241 minus 6150 on the other side, and that's 91. Okay, simply divide out, and we sold 7 pairs of Jordans. Okay, let's sub that back in. Let's go. Oh, we can actually just sub it back in right here. So n equals 75 minus 7, and I get 68. Okay, so therefore, they sold 68 Nike shoes, pairs of shoes, and 7 Jordans. That's what that point of intersection means. Okay, now we're going to take a look at a situation where we have 2 different investments, and we don't know how much money is in each of them, but we know how much interest we made. Okay, so Sally has $10,000 to invest. Okay, so we don't know how much is in each investment, but she has $10,000 altogether. She invests part, so we don't even know, so let's call this X, part of that savings into a term deposit that pays 5% a year. Okay, 5%, we know that we have to convert that into a decimal. And the remainder she puts into a Canada Savings Bond at 3% a year. And again, we have to turn that into a decimal. Okay, so what we're doing in this situation is we're talking about 2 different investments. Okay, so X is going to be the amount of money in the 5% investment. And Y is going to be the amount of money in the 3.5% investment. Okay, it's just like the 2 accounts. The amount of money in the first account and the amount of money in the second account are going to equal $10,000, because again, that's what Sally has from the beginning. Okay, at the end of the year, she's earned simple interest of $413. All simple interest means is money times your interest rate. Okay, so how much did X earn? Well, that amount of money earned 0.05 times however much money was in there. And the second the second investment earned 0.035 times however much money was in that investment. And altogether, those 2 amounts of interest equal $413. Okay, so we have 2 variables, 2 equations. The first equation is all about amount of money. The second equation is all about the interest, the amount of interest made on each investment, and then the total amount of interest made. Okay, now we just simply do substitution. I want to do substitution because we have X and Y by itself, no coefficients. So let's move that over. We're going to have X equals 10,000 minus Y. And let's go ahead and sub that into the second equation. 0.05 times 10,000 minus Y plus 0.035 Y equals 413. Okay, expand that in. So 10,000 times 0.05, we get 500. Minus 0.05 Y plus 0.035 Y equals 413. Okay, when we add these 2 Y's together, we get negative 0.015. And when we bring over that 500 and we subtract it, we get 413 minus 500, we get negative 87. Oh, sorry, there should be a Y on there. Okay, divide both sides by negative 0.015, and I get y equals 5,800. Okay, so in the second investment, that Canada Savings Bond, Sally invested the 5,800. Now let's sub that back into X. X equals $10,000 minus the 5,800 that she put into the Canada Savings Bond, and we get 4,200. Okay, therefore, she invested 4,200 into the term deposit and 5,800 into the Canada Savings Bond. Okay, that's what that point of intersection means. How much Sally invested into each investment. Okay, example 5. This example is going to be about two solutions, and what we want is we want to mix them to make a specific percentage. Okay, some of these examples are going to be about acid, alcohol, or like gold. Okay, so Julie has a bottle of 5% acetic acid and another bottle of 10% acetic acid. So basically what Julie wants to do is mix them together, and how much of each of these should she use to make 250 milliliters of 8% acetic acid. Okay, this question has one extra step in the last 2 or 3 questions that we've done. Okay, first of all, I want to just point out that 5% acetic acid and 10%, if you did 50-50, like if you mixed both them together in equal parts, it's going to be obviously 7.5%. But we don't want 7.5, we specifically want 8%. So it's not going to be 50-50. Okay, so we know we're going to make an equation about how much acetic acid she's going to mix together. So she's going to mix together X and Y, so the amount of X plus the amount of Y, and it's going to be 250 milliliters. Okay, so amount of 5% acetic acid and the amount of 10% acetic acid. Okay, now the second equation is a little bit different. So this is based on amount. The second equation is going to be based on the percentage. So of course, X is going to have 5%, and then Y is 10%. But here's the difference. For this solution, we have 8%, but each of these is like 5% times the amount, 10% times the amount. For this solution here, the equals, we have to have 8% times the amount, which we know, which is 250. This is where this differs. Okay, so let's solve this one. Let's bring that y over. We're going to have x equals 250 minus y. We're going to come back to that. Okay, so 0.05, 250 minus y plus 0.1 y equals, and let's just multiply this right away. So 0.08 times 250, I get 20. Okay, let's distribute this in. 0.05 times 250, I get 12.5 minus 0.05y plus 0.1y equals 20. Bring that over. We're going to subtract that 12.5. Okay, so we're going to have 7.5 on this side and 0.1 minus 0.5, 0.05y. Okay, divide out. At this point, it's just substitution elimination, so that's pretty easy. Okay, y is 150, and now x is going to be 100. Oops, x. Okay, so therefore, Julie must mix 100 milliliters of 5% acid, and 150 milliliters of 8% acid. Sorry, 10% acid. 10% acid. And that's in order to get that balance of 8%. So of course here, this makes sense that she's going to be mixing more of the Y, which is 10%, because it's heavier weighted on that 10%. Okay, the 8 is above the 7.5, which would be like the average. Okay, now we're going to take a look at distance, speed, and time problems. So if we recall back to physics in science class, the speed times the time is going to equal the distance. Okay, so in these questions, there's going to have to be a lot of common sense. Okay, so a canoeist took 2 hours to travel 12 kilometers down a river. Okay, so going down the river, which is 12 kilometers, it took him 2 hours. Okay, on the return trip, so if you think about it, common sense tells me the return trip is also, both of them are 12 kilometers. On the return trip, it took him 3 hours. Okay, so what we have to do is we have to find his average paddling rate, so his speed, so the speed of the canoeist, and then the speed of the current. So here's the common sense factor. 2 hours tells me the speed of the canoeist and the current work together. And 3 hours tells me the speed of the canoeist and the current work opposite each other. Let's put together here. Okay, so let's think about this. These are the two things that we're solving for. So let's put X is going to be the speed of the canoeist, and Y is going to be the speed of the current. Okay, let's use ST equals D. So ST equals D. Okay, so the speed on the way there is going to be the canoeist and the current working together, times the time, which is 2 hours, and the distance is 12. Now, the speed on the way back is going to be the canoeist working against the current because it took longer. It took 3 hours, and that's also going to equal 12. Okay, so here are our two equations, but they're a little ugly because the X and the Y are in brackets. Okay, the speed of the canoeist and current are working either together or apart, and that's going to be the total speed. So let's distribute the 2 into the bracket. So we're going to have 2x plus 2y equals 12. And now let's distribute the 3 into the bracket. 3x minus 3y again equals 12. Okay, for this one, we have x and y, so we have the two variables, and we have the two equations. So I want to point this out, the 12 and the 12, it doesn't matter if we're able to cancel those out. We always want to cancel out either an x or a y. Okay, so I'm going to use, substitution is going to be okay, but I'm going to use elimination just to switch it up. So I'm going to multiply the first equation by 3 and the second equation by 2. Let's see what we get. I'm going to put them down here. Okay, so we get 6x plus 6y equals 36, and we get 6x minus 6y equals 24. Okay, now let's subtract these two. So the x's go away, and we get 12y equals, what's 36 minus 24? 12. I get y equals 1. Okay, take this, sub it back into any of the originals. Okay, so I'm going to sub it back into this one here. 3, 1. oh, sorry, this is supposed to be x. 3x minus 3, 1 equals 12. So 3x equals 12 plus 3, which is 15, 3x, divide out, I get x equals 5. Okay, so therefore, there we go, the speed of the canoeist is 5 kilometers per hour, and the speed of the current is 1 kilometer per hour.